Let me welcome you all to this course on Internet technologies. Now, as the name implies, you can understand that as part of this course, we will be talking on various aspects about the Internet, the way it has evolved, the way it has, you can say, it has incorporated different technologies and techniques and applications under a single umbrella, making it the most, you can say, the most popularly used infrastructure in terms of information exchange and communication today. So in this introductory lecture, we will try to basically look into the way Internet has evolved over the years, the way the technology has developed. We would briefly have a look at the different important Internet applications that we have today. There is another important thing which also we try to talk about. It is the way a new standard is submitted and is recognized in the Internet community. We shall also look about it. And finally, we would have a quick look at the overall contents of this course on Internet technologies. We will be talking about what are the different topics and modules that we will be covering in course of the future lectures. So let us get started. The topic of today's discussion is Introduction to Internet. So first let us try to talk about what is an Internet. Now, as the definition goes, an Internet can be defined as the network which is formed by the cooperative interconnection of a large number of computer networks. Now, since Internet is formed by the interconnection of a number of computer networks, sometimes it is also known as a network of networks. Now here there are a few interesting things that work with the Internet. The first and foremost is that there is no single owner of the Internet. Now, just unlike a network that you can see in your organization, maybe your organization owns the network. In contrast, Internet, you cannot identify a single owner who owns or who administers or manages the whole network. Suppose you are a member of the Internet group, which means your computer is also connected to the Internet, maybe through a simple dial-up telephone line from your residence. Now in that case, you are also a part of the Internet. So what I mean to say is that every person who makes a connection to the Internet becomes a part of the owner. Okay. So I repeat, there is no central administration or central authority to the Internet. Now, just talking about the way Internet has emerged as a network of network, if you look into the history of computer networks, you will find that computer networks initially started in the late 60s. They were mainly some clusters of computers in different laboratories and organizations, where the main purpose was to connect several computers together so as to achieve a number of goals like exchanging messages, sharing some information, etc. Now the networks that were there at that time, they shared some characteristic like they were all proprietary in nature. The network that was there, which was connecting a number of computers, all the computers were of the same type or they were for the same vendor. For example, we could have had a network which comprised of only IBM computers, a network with only DEC computers, and so on. Now with the passage of time, people felt that, well, these kind of small networks have emerged in the different laboratories and organizations like small islands. Now as the requirement or need of the people grew with time, they felt the necessity to connect these networks together so that a user of network A can communicate with a user of network B. Okay, there should be a way of communicating between them. But of course, in order to do that, one big problem needed to be solved. That was the problem of compatibility. I told earlier that initially the networks are mostly proprietary. So a network of, say, that had connected a number of IBM computers were a totally unknown entity to an HP computer. The HP computer did not understand how the IBM network would work. So there has to be a common binding force or a common standard that would allow all the computers across these networks to talk or communicate among themselves. Okay, so this was one of the motivation. Now, talking about a network of networks, internet looks something like this. We have a number of such networks which are connected in some way. Of course, the picture may not look like this. The diagram, as I have shown, it is a pure star network, but in practice this does not certainly look like this. The purpose of this diagram is to give you a logical picture of the internet. There are a number of different networks which are all connected through some basic backbone network. The central place, this portion, this is the central backbone network which connects all the networks together. Okay, so the internet, what is it actually in practice? Well, internet is not just the network. Internet is not just the programs or applications that the users of the internet use. Internet is not just some document or some resources which are available on some computer in the network, but rather it comprises of a number of different things. Firstly, it is a community of people who use and develop the network. So people are also part of the internet. So without people, internet would not have existed. Internet also consists of a collection of resources. This is very important, because if these resources were not there, possibly so many people should not have used the internet. Now, by having a connectivity or this network of networks established, what we have is that these resources can be reached from anywhere in the internet. So we have some kind of network, and over the network you can reach any resource you want to from any other place. This is the basic idea. And internet also provides a setup to facilitate collaboration. Now, when I say collaboration, this can be simple messaging facilities like electronic mail, or it can be some more concerted collaborative efforts like having a bulletin board system where somebody can pose some problems, or a discussion forum through which you can start an open discussion on some topic which of course you want to start a discussion on. So particularly this kind of collaboration is very useful in a number of, you can say, areas, in particular among the members of the research and education communities. They find this kind of collaborative facility invaluable. Suppose I have a problem I am unable to solve. If I put it in the discussion forum, maybe somewhere sitting somewhere else would be able to solve my problem and give me a response or a solution to the problem. Okay. And talking about common standard that binds all the network together, there is a standard protocol called TCP and IP. TCP stands for Transmission Control Protocol and IP stands for Internet Protocol. So as the scenario is there today, well, any computer or any network, if it wants to get connected to the internet, the computer or the network must understand the language of TCP/IP. So all the message exchanges that go on in the internet, they use the syntax and the format of the TCP/IP message packets. So if your computer understands TCP/IP, then your computer possibly can become a part of the internet if you just have a connectivity to it. Okay. Now talking about the evaluation of the internet, it started as early as in the 1950s, where the US Defense Organization ARPA, it stands for Advanced Research Projects Agency, they started to network a number of computers that are funded by them in a very small way. So a few computers which are located in different parts of the country were provided with some sort of connectivity so that they can communicate among themselves. Now subsequently, well, it continued for some time like this. In 1970s and beyond, this ARPA became to know as ARPA network, Advanced Research Project Agency network. So ARPANET started to create a standard which is basically the predecessor to the TCP standard that we have today. So at that time the standard that was proposed, that is not exactly TCP, but it is a step in the right direction. So it was a preliminary protocol which through subsequent, you can say, refinements and modification became finally the TCP as we see today. In 1971, the universities were added to the network. The main purpose was that many of the defense funded research used to take place in the universities, and ARPANET felt that university should be part of the network, and some basic internet services like Telnet and FTP were made available. Now these we'll be studying later in more detail. Now using Telnet, you can start a remote session on a different computer sitting on your own computer, and using FTP, file transfer protocol, you can transfer a file or a group of files between two machines. These were the basic facilities which are provided at that time for communicating between machines. In 1972, the first version of electronic mail came into the, you can say, being, and the first email message was sent during that time. In 73, ARPANET spread its reach beyond US. It connected to some sites or locations in England and Norway. So it is in 1973 where ARPANET started to spread across continents. 1974, TCP was recognized as the standard, and it was used for communication across a system of networks. So you can say that in 1974, people actually started to talk about having a number of networks. They will all be speaking the same language, and TCP was the vehicle which was used to do or achieve this. Now in 1982, the US Department of Defense, it started building their own defense data network based on the same technology that was developed in ARPANET. You see, this ARPANET, as it has evolved, it also brought along with it a number of different technologies, some protocols, some standards which people used and were actually able to communicate. So the US Department of Defense saw that, well, here we have a technology which we can use to great benefit for our case or application also. So they simply borrowed the technology for their own application and they started using it. In 1983, this ARPANET actually got split into ARPANET, and there was a new network, military network, MILNET, which was created, which of course had some additional security requirement. That's why they got split into two. In 83, we saw the internet, which is very familiar to the internet we see today. So in 1983, the internet started to actually take shape as we see it. TCP/IP was recognized as a standard. Then in 1986, National Science Foundation, they started another network, NFSNet. Now NFSNet, the objective was very simple. The objective was to create a very strong backbone network used to connect the regional networks. Okay, as you can see here, this NFSNet is a system of regional networks which were connected over a backbone network. So here there were some networking devices called routers which were used, and routers belonging to the different regional networks were strongly connected among themselves, and this constituted what is called a backbone network. And the main purpose of NFSNet was to create a very powerful backbone network which would provide the so-called backbone for future generation communication systems. In 1991, some new applications like Archie or Gopher were released. Well, many of you may not have heard about these applications, Archie and Gopher. See, at that time, applications like the FTP, file transfer protocol, became very popular. People started to keep a large number of resources on the different FTP servers, and through FTP you can basically connect to that server and you can download the material, whatever you want. It is very similar to the World Wide Web that we see today. I am sure most of you have used the internet through the World Wide Web, through the browser, and you know how it looks like. But at that time there was no user interface, just you have to give a command, get a file, and after you bring the file to a machine you can open it and see what it is. Okay. Now the main problem the people used to face at that time is, suppose I want some resource, say I want a particular document on a subject. So how do I know where that subject or that document is located? Well, if know the address, at that time some big FTP catalogs were published, I can look at the catalog and find out where these documents are located in this FTP server. So let me connect there and see if I can find it out. So this Archie was developed as an FTP search engine. Well, many of you are familiar with Google, Yahoo, the search engines which people use today. So at that time Archie was a search engine through which, given a topic you want to search for, Archie would return a list of FTP sites where you could possibly get that topic. And Gopher was, you can say, a more intelligent version of Archie. Gopher showed you the documents in a category and subcategory view. It was like a global view. You can browse through categories and subcategories. Suppose flower, rose, black rose. If you click on black rose, you can get a list of places where you can get information about black rose. So this Gopher allowed you to browse the FTP sites through well-defined, you can say, category and subcategory view. Well, Gopher was a little more general. It covered the FTP sites as well as some other non-FTP sites also, but I am not going into those details right now. Well, in 1992, the internet linked more than 17,000 networks. There were about 3 million hosts. 1993, the World Wide Web application was launched. Today, you know, this World Wide Web is the de facto standard. Anyone owning a computer, they use World Wide Web. They use either the Internet Explorer or Mozilla, Conqueror, some kind of browser they use to access the World Wide Web. 1995, the concept of network service providers came into being, and this network service providers started to offer service. Like earlier, you had to build your own network, and it was your responsibility to get your network connected to the internet backbone. Now there are service providers. Well, in India there are service providers like VSNL, like Satyam, like Reliance. There are so many today. Now you can approach them, they will provide you a connection and it will be their responsibility to get your network connected to the internet backbone. Okay. So in 1995 you can understand you have about 30 million users. So the growth was fantastic. So this simple file shows you the exponential nature of growth that internet enjoys. You see, in 1989 from about 10 million hosts, in 2001 you have 100 million hosts. So over a period of time the number of nodes have increased in a fantastic way. So this exponential growth continues, and as of today we have more than a billion hosts which are connected in the internet. Okay, now as the internet came in place and it became popular with the passage of time, there were a number of internet applications that were developed. Some were accepted widely, some they were not accepted, and finally they got rejected. But here I am listing a few of the internet applications which became popular, in fact are still very popular, in fact all of them. The first one, Telnet, I told you about this. Telnet allows a user to log into a remote computer and start a so-called remote session. That means I am sitting on my computer, I am running a program, I am viewing a file, but actually everything is happening on the other computer. What I am seeing on my screen is the output of that program is coming straight away to my screen, and I am having an illusion that I am actually sitting on that other computer, not on my computer. Okay. Similarly, you can have file transfer protocol. This also I mentioned. Using this you can transfer file between machines. Then you have the so-called electronic mail. In fact, today email is the single largest application which is used by people. Well, every person who gets connected to the internet invariably uses email. This email has become, you can say, part and parcel of our daily life and is very fast making the so-called surface mail, which somebody also calls snail in comparison with the speed. So the surface mail is becoming obsolete and redundant in many cases. Many of us today prefer to send documents and reports by email rather than by surface mail. Gopher I had mentioned. Gopher, although today you do not see many Gopher application, but there was a time in the 80s and mid 90s where Gopher was very popular. It was, you can say, just a previous version of the internet as we see today. So through Gopher you could browse through categories and subcategories, you can access the document or the resource you want to access, and you can use it in a convenient way. This internet relay chat is another application which is also very widely used by people. Through this internet relay chat you have, you can say, a medium through which a number of persons can communicate among themselves. Well, if I type in some message, that message can be viewed by all members of the group with whom I am participating in that chat. So this chat is a very useful tool, and if used in the proper context can prove itself to be extremely useful and beneficial, particularly in education. This Usenet News, this is also a very important application. News, well, broadly this is like a discussion group, news group, or a discussion forum. Say I have a discussion forum through which I can start a discussion. I can float a topic. The other members of the community who are also there in the forum can post their views. I can see them. Well, as I mentioned, if I have a problem, I post the problem on the discussion forum, and someone else may be coming up with a solution and posting it there. Well, the advantage is that I may be having my personal problem which I have posed, and someone else have posted a solution to this, but there may be a number of other people who are having a similar problem. So if they look through the mails that are getting exchanged through the discussion forum, they can possibly also find a solution to their problem automatically, okay, by just following the discussion that is going on. And of course, lastly, you have the World Wide Web, which is the most important application that we have today. In fact, today World Wide Web can be treated as an umbrella, and under the umbrella all other protocols can be used, like electronic mail, like FTP, like news groups. Everything else can be accessed under the same umbrella of World Wide Web. So World Wide Web, well, in itself it's an application, and it also integrates other applications together, okay. So today we have a single common interface. We start a browser, and through the browser we can basically access everything, okay. Now let us talk about something else. See, this internet has evolved over a period of time. There are new protocols which have come up. Many of them have become so popular. Now suppose a new protocol comes up. Let's take an example, say the email, electronic mail. Now you know, today all the machines, all the computers, all the operating systems, they support electronic mail, and somehow they are compatible. If I send a mail from one computer to the other, it reaches the destination. So you can guess that there has to be some kind of a standardization effort that goes on somewhere. Like suppose I am a company, I manufacture computers, I manufacture operating systems, I design software. So if I want to build a computer system which also will be having a mail system, which will be compliant or compatible with the other systems around me, then I must know what this email standard is. How am I to develop this software? So the question of internet standards come into the picture. Now I have mentioned in the internet there is no central agency, no central administration. So how come these standards are enforced? How come these standards are published? Well, there is a well accepted and practiced way of doing it. Let us now look at this. These internet standards are also called request for comments or RFC documents. Now let us try to see what these RFC documents are and who are responsible for the publication of these and how are these get standardized. Okay. So first let us look at some of the internet societies. Most of them are, these are basically voluntary organizations. They are essentially non-profit organizations. They are created in order to bind the different activities in the internet together. They are basically voluntary organization. Maybe I can be a member of such a group if I want to. Okay. So let's see. In the so-called internet society, we have three groups. One is called the Internet Architecture Board, IAB, Internet Engineering Task Force, IETF, and the Internet Engineering Steering Group, or IESG. Now these groups have been created, they exist, and each of them have some well-defined goal. But here we are more interested in the process through which these requests for comments or RFC documents are published. Now when a new RFC document needs to be published, well, means a new working group has to be formed, but working group is not that well defined in a sense. For example, if I come up with a new suggestion, so means I understand or I believe that I have discovered or designed a protocol which should be very beneficial in the internet environment. So what I do, I can approach those groups, and those groups can formulate or frame a working group of which I can be a member. So there will be working groups which will be formed like this. Mostly they will be coming forward and these working groups are supported or chartered by the IETF. So the whatever effort I am putting, this IETF will be supporting my effort. As I said, membership is voluntary. Well, working group, well, myself and my team members can be part of the working group, which will be negotiating the standardization of the protocol that we have developed. So in this way there can be several other working groups spread all around the globe, and they can be independently working on a number of different aspects of the standardization process. Now let us see. The basic process involved is as follows. The working group will start by making a draft version of the document. Suppose I have a new idea, as I said, a new protocol we have designed. So we first write down our protocol details in the form of a design document. That is the draft document that the working group designs. Then this draft document will be placed in the internet draft working directory. This is an online directory which other members of the internet community can also have a look like. Now that anybody at any time cannot put a draft in this internet draft directory. Before doing that, you have to get an approval by the IETF. That's why your working group must first be, you can say, approved by them. Only then you can submit your design document or draft to the internet online working directory. So this is the internet draft. Now after that, what happens? This is an online directory which is accessible by everybody. This internet draft will remain there for 6 months. 6 months is the limit. So within the 6 months, feedback, reviews and comments will be received by the different members of the internet community. So after that, those reviews and feedback will be analyzed, and it will be decided that whether to go ahead with this standardization or this is no good, no one likes it, so let us reject it. So over this period of 6 months, reviews and comments on the draft are obtained. Now the ISG group may now approve the publication of the draft as an RFC if the feedback and the comments that have been received are favorable. If a large number of people feel that the standard merits publication as an RFC, so just one thing let me tell you, this RFC is a standard document. There are thousands of such RFCs available, but out of them only a few have been actually implemented and has become popular. So just having it as a standard does not always mean that it has to be a very popular standard which everyone uses. Okay. So this ISG, this Internet Engineering Steering Group, this can approve the publication of the draft as a request for comment document within this 6-month period. But if it sees that the comments are not favorable, then it is simply withdrawn from the directory. Okay. Now the working group, well, after it has been published as an RFC, the working group may subsequently refine the draft to produce revised versions of the protocol. Suppose in the initial version we had proposed a protocol which had a version 1.0. Subsequently we can come up with a version 1.1, 1.2 and so on. Now, although anyone can come up with a revised version, but the IESG will always try to get it approved by the original working group who had come up with the original draft, the first version of the draft. Okay, right. Now let us diagrammatically see that what is the process that gets involved. Here, this internet draft, this is the place where the initial drafts are submitted. Now after the initial drafts are submitted, after the 6 months period comments are obtained, as I said, so after that, depending on the comments, the draft can go to one of three places. Of course it can be rejected, I am not showing the rejection here. Well, some of the drafts may be accepted as an informal RFC, informational RFC. Well, informational RFC means it is an RFC which does not specify a standard, but rather it is something like a tutorial. It gives you detailed insight about some particular topic which the IESG feels that this is important for the internet community. So let us also publish this as an informational document or informational RFC. So this is one type. The second type is that you can also publish a document based on some experimental results. Suppose I analyze the nature of internet traffic, what kind of internet applications running, what kind of bandwidth they consume, what kind of pattern they follow. Now this piece of statistics may be useful to a large number of people over the internet. So if I prepare a document which would be highlighting these things, this would be more like an experimental data or experimental results. So there can be some draft which can be experimental in nature. But the drafts which are basically meant to be accepted as a standard, first step, they gets accepted as a proposed standard. Then after revision and comments, draft standard is prepared, which finally over a period of time gets accepted as an internet standard. So these shaded boxes, these green shaded boxes, they are the temporary states. Okay, these are temporary states. This internet draft, proposed standard, draft standard, these are temporary states, whereas this internet standard, experimental and this informational, these are more or less permanent states. A draft can remain in this state for a relatively long period of time, several years. Of course, after certain time, the ISG may feel that, well, there were some RFCs which were important, but in the present day context they have lost significance. So let us move it to the so-called historic state. They will remain, but they will remain as a historic document. This has some historic significance, but not so important in the present day context. Okay, so in the present day context, only those documents that are important, they will remain either in the internet standard or experimental or in the informational states. Okay, so this gives you a rough idea about the publication of RFC. Now let us see why. Number one question is that you may argue that, well, I know that these RFC standard documents are there, but if I want to look for some standard, where do I look for? There must be some places where I should find them. Okay, yes, there are, but first let us quickly look at some of the important RFC. As I mentioned, there are thousands of them. For instance, RFC 821 refers to the mail transfer protocol, SMTP. This is the email standard. This RFC 791, this refers to the IP protocol of the TCP/IP, okay, internet protocol. 793 refers to the TCP. 2616 refer to the hypertext transfer protocol, that is the protocol which is followed between a web server and a browser for accessing web documents. Similarly, 2045 is for MIME, which is also for electronic mail. This 1321 is used for security, for message authentication. RFC 1866 for hypertext markup language, which are used for designing web pages. And 2467 again for cryptographic application, 2631 also again for some cryptographic security applications. Now if you want to search for a particular RFC document, of course you can go to a search engine like Google. Suppose you are trying to search or look for the RFC document for FTP, You can always give the search keywords RFC, FTP and press enter, and you'll find a list of sites where you can get them. But you can also look at a number of so-called RFC oriented sites. Here I have listed 3, but there are many others. So you can just visit these sites: www.facts.org/rfcs, www.ietf.org/rfc.html, or www.rfc.net. So here you will get all the RFCs, the details. You can have a look at it, and if you want you can download it on your computer. Whatever you want you can do with it. So these RFC documents are all available online, and anyone, particularly the persons who want to know about the protocol from educational point of view, from knowledge point of view, or even persons who want to develop some tool which will be conforming to some standard. So these RFC documents are the authentic standard documents. If you want to have your tool to be compliant with the other tools that are available elsewhere, you must ensure that your RFC document, whatever specification is there, that must be adhered to. Okay, fine. So now let us have a quick look at the contents of the topics that we will be covering during the course of this particular internet technologies coursework. Okay, so we take a quick look at the topics to be covered. Well, in the first module, we are going ahead with lecture 1. Now in our next lecture we would be taking a quick review of network technologies. Well, here I expect that most of you have some basic background of computer networks. Well, but there may be a few of you who does not have significant background in computer networks, or maybe you have studied some concepts some time back, you may not remember them. So to make this course, you can say this course module complete, I will brush through the basic concepts of computer networking in the second lecture, so that the relevant terminologies and concepts which may be required in the subsequent discussions would be refreshed. Well, in the second module we will be looking into some detail regarding the standard, as I told you, the TCP and IP protocol, transmission control protocol and IP protocol, which, as I mentioned, is the basic driving force behind the internet. Now here, just let me tell you, this TCP IP, this is talked about as a standard. Now actually TCP and IP are two different protocols, as we will see in detail as we proceed through these lectures. Now the basic task of the IP protocol is to ensure that the message packets that are being sent to a particular destination, they follow the appropriate route and they finally reach the correct destination. It is the responsibility of the IP software, or the IP network layer it is sometimes called, to ensure that packets are delivered at the destination. But TCP, in contrast, this is a protocol or a program which is interacting more closely with the user application. TCP ensures that a message that is being transmitted to a destination gets transmitted in a correct way. Well, a message may be long, it may have to be divided into smaller message packets, which will be in turn given to IP for actual transmission. So all these things will be covered in detail in the second module. So we will be having 3 lectures devoted to this. Well, in the third module we will be looking into some more detail regarding how the IP layer ensures that packets are routed or forwarded in the correct direction. So I had mentioned that one responsibility of the IP layer is to ensure that packets that come, they reach the correct destination. But this cannot happen by magic. Obviously IP layer has to take some decision based on the destination address of the packet and a few other factors, and this is certainly not a very easy task. This is an involved thing, because as you can understand, I just told you that all across the world there are billions of computers. So how do you ensure that any destination address belonging to any computer, the packet will finally find a way to it through some path? This has to be some, you can say, standardization or some standard algorithm for ensuring this. So here we would be talking about, first thing is IP subnetting and addressing. This is one topic where we will be basically talking about how we can make more efficient utilization of the so-called IP addresses. Now in the IP protocol, all computer addresses are treated as 32-bit quantities. So how to best utilize these 32 bits? We shall be having a look at this. Then we shall talk about internet routing protocols. There are 2 lectures devoted to this. Now when we talk about internet routing protocols, we are actually talking about IP. Now here again, there are a number of different scenarios. There can be several routers which belong to the same place, same organization. There can be routers which belong to different organizations. The kind of messages they should exchange among themselves, so that they have the power to take the decision that where I will be finally forwarding a packet given the destination address, that decision becomes a reasonably correct one. So there are a number of approaches and algorithms used for this. We would be discussing about these, and we would also talk about the next generation of IP, that is called IP version 6, which will see, which actually improves upon the present IP version in a number of different ways. Well, all these things we will be looking into the detail. In module 4, we will be looking at the common internet applications. First, we will talk about the basic, because the platform on which these internet applications are based, these are the client server application. Then we will be talking about the domain name system, DNS. Then some applications, telnet, FTP, email, and finally World Wide Web. Now as part of these lectures, we will be looking not only at how to use these protocols, but also at the basic technology, the basic underlying technology that is used to make these protocols work. For example, when you talk about World Wide Web, we will not only see how to use the web. You already know, just through the browser, if you type in some address, you basically get back a page. But we would also look at what is the basic underlying network technology, what kind of messages get exchanged between your browser and the web server, how do they send back the message, how do they send the request, and so on. So all these things would be discussed in module 4. Now in the 5th module, we will be addressing the problem of creating web pages. Now if we talk of the World Wide Web, there we have an infrastructure, we have an interface through which you can access some resources. Now here in this module, we will be addressing the question, how are these resources formatted? If I want to write a document which I want to put on a server, on a web server, how do I write it? Now most of the documents, they get created in a language called Hypertext Markup Language, or HTML. Now in 3 lectures of this module, we will be talking of various aspects of HTML. What are the different ways we can format the text? For example, how we can change colors, changing font size, styling, formatting text, centering, justified, including tables, including images, how we can provide links to other documents, bulleting, frames, and so many other things. So here our idea would be to give you some basic background about HTML so that you can write a web page directly in HTML and you can get the desired feeling as you had intended to. And in the last lecture we will be talking about XML, which is fast becoming emerging standard. Well, HTML is a static language. This HTML supports a few features which are fixed by the definition. In contrast, XML is a language where you can expand the capabilities of the language. So most of the modern browsers, they support XML, and even the future generation of HTML, they will be based on XML. So this XML is something which is very important, which I feel that everyone should know about. Well, in the 6th module, well, here also we'll be talking about designing web pages, but interactive web pages. This is something a little different from what we talked about previously. Well, in the conventional or so-called static web page, what we actually do is that there we have some document which we call as web page located on the web server. From the browser I can send a request, that web page comes back to me, I can view it. But in some cases there has to be a two-way communication between the client, which is the browser, and the web server. Let's take a very simple example. So you know that today most of the examination results are published on the internet. Suppose I want to look at my result. So I visit the website where the result is published, I type in my roll number, press enter, and after some time I get back my name, my result, everything. See, my name, result, everything, well, it is not expected that this same page was residing in the web server exactly in this form. Must be this was there in some database. In response to the roll number I have typed, somebody on the other side extracted the information from the database, composed it in a suitable form and sent it back to me. Okay, this is what we mean by interactive web pages. The web pages are not static, but they are generated dynamically based on the user requests. So for generating these interactive web pages, you can have so-called HTML forms in conjunction with so-called Common Gateway Interface or CGI scripts. This we will see in detail later. Now in addition, you can have something called image maps, where you can have a picture, and if you click on a part of the picture, you go somewhere. You click on some other part of the same picture, you go somewhere. Just imagine that you have the map of India, you click on a state, you go to the website of that state, something like this. And of course at the end we will be looking at other technology, because the number of technologies are too many, and it is not possible or not advisable to teach all of them at the same time. So we will be concentrating on some technologies like the active server pages, for example ASP. There are other technologies like PHP which are also there. There are many others. So we will be concentrating on one such technology and see that how using that technology also we can develop this kind of interactive pages in a very easy way. Now in the 7th module we will be concentrating on learning a new language, practical extraction and reporting language, in short Perl. Well, there will be 4 lectures devoted to Perl, and the purpose of teaching Perl is Basically, Perl is a very nice language which has extremely powerful string handling capabilities. Now you will see later when you discuss, say for example, CGI scripts, you will see that when we develop this kind of interactive applications, when we develop a program which is a CGI script program, you need very powerful string handling capabilities, and possibly Perl is a very good candidate for this. There can be other alternatives also. Perl is not the only choice, but Perl is a very powerful language which is used by many people for developing CGI scripts, and so we would discuss Perl in some depth. Then in the next module we will talk about JavaScript and be spending 3 lectures on it. JavaScript, essentially this is an extension of HTML, you can say. It runs on your browser and provides with a number of different very attractive facilities like moving messages, some window popping up, some automatic checks. You type in something, if it is not within a range, immediately an error box opens up, and a number of such features are there. Some menu bars coming. This kind of things can be done using JavaScript in a very simple way. So we'll be seeing that how we can use JavaScript to make your web pages more attractive. And we cannot leave out Java from the internet, because Java was a language which was primarily designed to be used in the internet. In fact, there are many applications in the internet which use Java, and we will see that means what are the advantage Java offers. Java programs which are used in the internet are called Java applets. So we will be looking at Java applets, and also we will be looking at how using Java we can communicate between 2 machines which are called client server programming. In module 10 we will be talking about internet security, because security is very important in the internet context today. So we will be talking about intranet, extranet, firewall, how we can make our networks secure. We will be talking about the basic cryptographic concepts in the next 3 lectures. Then we will basically talk about authentication, we will be talking about encryption, decryption, and a number of related issues. So means we want to develop an internet application, how to make it safe and secure. There are a number of issues involved. In module 11 we will be talking about some miscellaneous applications, e-commerce, real-time application, IP telephony, web crawler, search engine, and some other miscellaneous application topics. And finally, in the last module we would be looking at some of the case studies. Well, here we try to look into the detailed design of this. For example, we can look at web-based mail, we can look at the design of a proxy server. And in the last lecture we will give you a flavor that how an internet application can connect to a back-end database. Well, although this falls under the purview of information system design, but there are many internet applications which in fact rely on some data stored in the database. So we will see that although front end we are using a browser, back end on the server side there can be a database, how we can extract data from the database and develop an application from there. So with this we come to the end of our introductory lecture today. Thank you.